Hello, ladies and gentlemen. Once again, coming to you not quite live from One Take Studios. Today our topic is operations with complex numbers. By way of reminder, complex numbers typically are imaginary numbers. Technically, the number 5 by itself is also a complex number. However, today's focus is going to be the imaginary portion of the complex numbers. I've got a whole bunch of odds and ends for you here. No single thing by itself is a tragedy, so we're just looking at getting a few things done here and there. We're going to start with graphing, and I can already hear the groan coming through the video here. Oh no, graphing, whatever shall we do? How do we graph something that looks like this? So this is standard form for a complex number, a plus bi, so it's going to be -1 plus 4i. How do I graph that? Well, we're going to make some slight changes. This is not going to be the x-axis and the y-axis today. This is going to be the real axis and the imaginary axis. So instead of x and y, we have the real axis and the imaginary axis. So I've got a couple colors here. Let's see if we can make these show up reasonably well. I'm going to start with this guy, and I'm going to give him a red squiggle around it just so that we'll know that he'll coincide with the red graph. Now, what do I mean by graph? Well, -1 is the real part. Here's the real axis. Here's -1. 4 is the imaginary part. This is the imaginary axis. -1, 1, 2, 3, 4. I'm going to make that point a little bit bigger maybe than I normally would, and hopefully you can see that it is red and coincides with this right here. -1 plus 4i is kind of like the ordered pair -1, 4. We graph the real part, we graph the imaginary part. That is the graph. A single point, that's it. That's the graph. Okay, all right, that's not terrible. Let's jump to this guy over here. 2 minus 3i. I've got this one in green. I don't know if you can tell. I'm hoping that you can. All right, so that is a lovely green color. It doesn't show up super green. Anyways, 2 minus 3i. At any point in time in this video, you should pause it and see what you can figure out on your own. So feel free, go ahead, pause it, try to graph these two things and come back to me. Go, pause. Did you pause it? I hope you paused it. 2 minus 3i should be where? 2 is the real part, -3 for the imaginary part, so 2, 1, 2, 3. That is this guy right here. Again, graphing a little bit larger, hoping maybe you can kind of pick up the color that goes with that. Okay, so that's not crazy. I've got purple. Let's see what purple shows up as here. So -i is a pure imaginary number. That's supposed to be purple. And it's just the -i part. There's no real part, which means that the real part must be 0. Oh, 0. And I just have -i, so the imaginary part is -1. Ladies and gentlemen, that right there is the point for -i. Graphing is not a tragedy here. It really, really isn't. You can do this. To graph a number, real part, imaginary part, take the place of x and y because we are relabeling our graphs. This is our real axis. This is our imaginary axis. All right, while we are on this topic, I want to talk about absolute value because this is going to seem kind of crazy, but if you understand what absolute value is, it makes sense. So I'm going to just use one of my numbers here, the absolute value of -1 plus 4i. All right, absolute value of -1 plus 4i. Please note that's the absolute value, long bars, not crazy ones. There we go. That was this point right here. Absolute value. Well, on a number line, absolute value, that was the distance from 0. Huh. So if this is where I'm located and this is 0, the absolute value of -1 plus 4i is actually asking for how far am I from 0? That's weird, but completely doable, because what if I just do this? And now all of a sudden, I've got a right triangle. If I want to know how far this point is from 0, shortest distance is a straight line, that's my hypotenuse. This, we went back 1, so this has a width of 1, and we went up 4. So if I'm trying to figure this out, I'm just thinking a squared plus b squared equals c squared. Some of you might be thinking distance formula, but honestly, they are the same thing. All right, so if I want to know the hypotenuse for this thing, we're talking, I'm going to have to do a squared, so 1 squared, plus 4 squared, and we're looking for the hypotenuse, so we're going to have to take the square root of that. Ladies and gentlemen, that's how I'm going to find the absolute value for this complex number. I'm still looking for distance from 0 because that's what absolute value is distance from 0. But a squared plus b squared square root gives me my c, my hypotenuse. So let's see, that's 1, that's 16, this is the square root of 17. Ladies and gentlemen, did you know that the absolute value of -1 plus 4i is the square root of 17? That's it. That's distance from 0. Some of these are definitely easier than others. -i. It's on the axis. How far is it from 0? I don't even need to do calculations. So again, absolute value of -i is going to be what? Well, distance from 0, it's 1. It is 1 away from 0. I can count. It's not on a slant, no diagonals, no hypotenuse necessary. That's it. The absolute value of -i is 1. Alright, so nothing super crazy, it just seems weird, but we're applying ideas we've seen before, and we're just doing it under new circumstances. Alright, so we can do graphing, we can do absolute value. Can we do some addition subtraction stuff here? That's where we're going to go next. Again, you may shock and amaze yourself with things that you already know if you just pause the video. I encourage you, pause the video, see if you can add and subtract without me. Pause now. Did you pause? I really hope you paused. Think about this. Yes, we're adding. Yes, it's complex numbers, but isn't this really just adding like terms? And you can do this. A 4 plus a -6 is -2. 2i plus -7i. That's -5i, and done. Ta-da! I can add complex numbers. Ah, yes, but can I subtract? Dun, 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 dun! Please be careful. You are subtracting this entire number. And if people are going to make a mistake, that's usually where they make it. So we're talking 5 minus -2. 5 minus -2, that's 5 plus 2, that's 7. And then -2i minus -3i. -2 minus -3, that's plus 3, that's just 1i. Alright, there we go. Ladies and gentlemen, I can add and subtract. You've been doing this for a long time, just combining like terms. It's the same thing. Yes, there are parentheses. Oh no, there are parentheses. Please don't be afraid of that. The only thing that might mean is if you're subtracting, that you need to make sure that you remember to subtract everything that is part of that second complex number. Alright, so you can see we've got adding, subtracting, we've got multiplying up next. And again, if you hit pause, take a look at this. You can do this, or at least most of it, without me. Give it a shot. Tell me what you think. Pause. Are you back? Did you pause? Let's see, this looks like the distributive property. Maybe that's because it's the distributive property. Sound effects make life better. What is -2i times 2? That would be -4i. What is -2i times -4i? Well, pretend this was an x, pretend it was a variable, what would you do? The -2 times the -4, you would call that a positive 8, and then if it was x times x, you would say I squared, you would say x squared, giving away the ending. I times I is I squared. So the only thing different here is a separate thought. Go back to the definition of an imaginary number. Imaginary number I is the square root of -1. So if I is the square root of -1, think for a second, what would happen to this if I squared both sides of this little mini equation? That would mean that I squared would have to be equal to, well, what happens to -1? If I have a square root and a square, those are inverse operations, they cancel each other out. Ladies and gentlemen, I squared equals -1. Alright, that is an important note to self. I squared equals -1. To completely destroy your brain, that means that if we take an imaginary number and square it, we end up with a real number. Yes, I just said that out loud. So that means that if you have I squared in your problem, you're not allowed to leave it there because you can simplify. Replace your I squareds with your -1. So this is -4i plus 8. Instead of 8 times I squared, it becomes 8 times -1. Which means it's -4i minus 8. If you are really fond of standard form, you can call this -8 minus 4i. Usually I myself am not that picky about it. If you want to call it -4i minus 8, I'm okay with that too. So we can graph, we can do absolute value, we can add, we can subtract, we can multiply. You know what? I'm not done multiplying yet. Okay? I am not quite done multiplying because there's a couple more things we should see here. Alright, so before we get to division, which is a whole horse of a different color. Did you catch the reference? Maybe, maybe. This, okay, is not just the distributive property, but it is something that you know and love. A binomial times a binomial. This is simply foiling. And so it's going to work very much the same way. 3 times 4 is 12. 3 times negative I, that's minus 3i. 6i times 4, that's 24i. And 6i times negative I, careful with the signs, that's a negative 6i squared. Negative 6i squared. Combining my like terms, that's going to be, wait a minute, like terms. What did we just say about the I squared? The I squared is negative 1. So this is not negative 6 times I squared. This is negative 6 times negative 1. This really just means plus 6. So that makes these guys like terms. 12 plus 6 is 18. And then I've got a negative 3i plus a 24i. That'll make a grand total of positive 21i. That is my final result from simplifying. Yes? Again, please pause this at any time. Pause it and try it yourself. See what happens. Guess what happens here? There's a reason I'm doing this one. Okay? Just guess. What do you think? Got an idea in mind? If we go back to FOIL, 2 times 2 is 4. That's going to be minus 18i. That's going to be plus 18i. And positive 9 times negative 9, that's a negative 81i squared. But again, what does that mean? If this is negative 81 times negative 1, because we said that I squared is negative 1, we're talking this really represents plus 81. So therefore, 4 plus 81, those are like terms. I can put those together. I can call that 85. And then minus, wait a minute, minus 18i plus 18i? Those are opposites. Those drop each other. The answer is just 85. So again, it's possible for me to just multiply a couple of complex numbers and end up with something real. It can happen. Okay, so you're probably reasonably comfortable with this. This last part is the one that messes with people's minds. Are you ready? Here we go. One of our rules for radicals says that we cannot have a radical in the denominator. What is I? I is the square root of negative 1. I is a radical. We can't have a radical in the denominator. So this is not division in your traditional sense. This is division in terms of, wait a minute, I can't divide by I. I'm not allowed to have that there. Whatever shall I do? If only there was a way, if only there was some kind of way to get my I to not be imaginary anymore. I wonder if there's a... Wait a minute, if I do I times I, that'll give me a real number. So hey, let me do this times I, because that'll give me I squared, and that'll fix my problem. But I do need to do the same thing top and bottom to fraction, keep the balance, so I'm also going to multiply the top by I as well. So that's going to give me, if I distribute 3I plus 10I squared, thinking about that, over, this is going to be 5I squared. So, that's 3I. This is 10 times negative 1, so that's minus 10. Over, again, that's a negative 1. That's negative 5. And again, you can rearrange this. You can put this into our delightful standard form. I'm not going to do that right now. I'm going to call that good. Because do I have a radical in my denominator? No, I do not. Therefore, ta-da! If you wanted to keep going, you could call it 2 minus 3/5 I would be the complex number standard form, for those of you that like that. Okay, which leaves us to, the final. What are we going to do with this? What do you mean, what are we going to do? We fixed that one easily enough. We just multiplied by I, and it made it so that it was real. Okay, so let's multiply this by I. Let's see. If I multiply this times I, this will be 4I and then minus 2I squared. So I will have fixed this I but I will have created another imaginary piece? That's not quite going to work out. I can't just multiply this one by I. What's the difference between these two denominators? 2 terms, 1 term. If you have 1 term and it's imaginary, yeah, go for it. Multiply by I, call it I squared, which means it's real. Excellent. But if you have a binomial, multiplying by I isn't going to work because you would need to distribute the I, and that would fix one problem while causing another problem. If only there was a different way. If only there was something else where you could multiply a binomial times a binomial and have it end up as something real. I wish I had seen something like that recently. Oh, wait a minute. What is this? Binomial times a binomial and it's real. Can I model this? Can I make this happen? Why, yes, I can. These are called complex conjugates. You can also think of it kind of like difference of squares because it's sort of the same thing, kind of a little bit. But yeah, this is complex conjugates. If I do 2 plus 9i times 2 minus 2i, I'm left with only real things. Well, so for minus 2i, I would need to multiply that by, what do you think? 4 plus 2i. But again, I have to do same thing top and bottom, keep the balance in my fraction, so I would also need to multiply the top times 4 plus 2i. And is this going to get a little bit tedious? Yes. Will you survive? Yes. Pay attention. Just pay attention. That's all. We're going to FOIL and FOIL. So we are talking, that's going to be 8 plus 4i. That's going to be plus 32i, and that's going to be plus 16i squared over, that's going to be 16 plus 8i minus 8i, and then negative times positive is a negative 4i squared. Okay, so again, just think about this. That drops with that. Positive 8i, negative 8i. What is this, really? This is a minus 16. What is this? Really, this is a plus 4. Again, because I squared is negative 1. So, I'm going to bounce over to my next line here. I've got 8 minus 16. 8 minus 16 is going to be negative 8. And then 4i plus 32i, that's a grand total of 36i. Over, the imaginary part's dropped. That is now real. 4 plus 6, that's going to be 20. There we go. Again, if I want to leave it like this, I can accept that. Please watch that you simplify, because there's a delightful factor of 4 that will come out of all of these. So I'm going to cancel a factor of 4 from the top with a factor of 4 from the bottom. What that might look like is something like this. Let's say I pull the 4 here. That's going to be negative 2 plus 9i. And I pull the 4 here. That's going to be 4 times 5. So I'm canceling a factor of 4 at the top with a factor of 4 for the bottom. Leave me with negative 2 plus 9i squish over 5. Ladies and gentlemen, that is considered an acceptable format for complex numbers and dividing, so that we no longer have an I or a radical in the denominator. Again, if you'd like to call this standard form, it's going to be negative 2/5 plus 9/5 I. But like that is usually okay as well. Alright, so be careful. A lot of tiny things here, but nothing super crazy. This is probably the weirdest part of it right here. Okay? So keep your eyes open. Watch your details. Watch the eyes, watch the negatives, okay? And start singing Swedish techno music. Ace of Base, I saw the sign. Yeah, do that while you're working on this, would you?